Chapter 3. The Periodic Classification of Elements. Introduction. Till today, 114 elements are found in the world. Every element shows different physical and chemical properties. For example, iron granules attract towards magnet. When a piece of sodium is added to water, it immediately burns with blast. These elements, when they react with other element or compound, give different chemical reactions and produce different chemical substances. Like ammonia gas is produced by the reaction between nitrogen gas and hydrogen gas. Moreover, zinc sulfate and hydrogen gas are produced when zinc reacts with sulfuric acid. It is difficult to understand properties and uses of each element at a time. It is necessary to have basic rules to understand method of reaction of every element on the basis of their properties. If elements are classified by the study of these rules, it will be easy to understand their properties. Thus, study of properties and uses of elements become easy if all the elements found are arranged properly. Concept of Dauer and Newland. In the year 1803, Dalton gave us information about the atomic mass of elements. All the elements which were found at that time are classified on the basis of their atomic masses. Concept of Dauer. In 1817, German scientist Dauer began to classify elements on the basis of chemical properties. He showed groups of 3 elements having similar chemical properties. In this kind of arrangement, when 3 elements are arranged in the increasing order of their atomic mass, the middle member of triad has the average atomic mass than that of first and third member. Like in the triad of lithium Li, sodium Na and potassium K, atomic mass of lithium is 7 unit and potassium is 39 unit. Average mass of lithium and potassium is 7 plus 39 upon 2 is equal to 46 upon 2 is equal to 23 unit, which is equal to atomic mass of middle member sodium. Similarly, atomic mass of bromine is calculated on the basis of atomic mass of chlorine and iodine, and by the atomic mass of calcium and barium, atomic mass of strontium can be calculated as given in the table. Dauer triad of elements. With the help of Dauer triad, different elements with same properties are classified into the group of 3. Limitation of this method is that triads of very few elements are found. Fluorine F can be added into triad of chlorine Cl, bromine Br and iodine I. Similarly, in the triad of calcium Ca, strontium Sr and barium Ba, magnesium Mg can be added. Thus, instead of triad, the possibility of group for classification seemed practical. Concept of Newland. In 1864, Newland arranged elements in the increasing order of their atomic masses. He found that the 8th element has similar chemical property to the first element of the preceding series, like musical octave, sa re ga ma pa dha ni sa. He called it law of octaves. Arrangement of elements according to Newland's law of octave. On observing the table on the basis of Newland's law of octave, when elements are arranged in the increasing order of their atomic masses, then eighth element sodium was placed below lithium having similar properties. Similarly, ninth element magnesium was placed below beryllium having similar properties. Newland was the first scientist who arranged elements in the increasing order of their atomic masses. By arranging elements in this way, it is found that their properties have systematic relation. Vertical column in the table are called as group, whereas horizontal rows are called as period. Though many scientists have contributed for development of periodic table, the credit goes to the Russian scientist Mendeleev. Periodic table of Mendeleev. Classification of elements. The periodic table. In 1869, Russian scientist Mendeleev found that there must be a systematic relation between elements by the study of atomic masses and basic chemical properties of these elements. Therefore, elements were arranged into various groups according to their basic properties as well as chemical properties. Mendeleev prepared periodic table of 63 elements known at that time on the basis of their chemical properties. He arranged elements in 7 groups on the basis of their increasing order of atomic masses. In this arrangement, elements in the same group have similar chemical properties. He thus proved that the properties of the elements are periodic in nature based on their atomic mass. This is called Mendeleev's periodic law. The vertical column of the periodic table is called group, while the horizontal row is called period. Periodic table of Mendeleev, 1871. Mendeleev did not place titanium below aluminium, but placed below silicon on the basis of similar properties. Thus, a place below aluminium remained vacant. If periodic law is correct, one has to find some element for this vacant place. He predicted that the unknown new element must have atomic mass more than 48 and its properties must be similar to those of boron B and aluminium Al. After 5 years, this new element, gallium, was discovered and Mendeleev's prediction according to periodic law was found to be true. Thus, gallium is placed below aluminium. Mendeleev's periodic table is as below.